Welcome to episode 155 of Paper Brief, where we dive into the fascinating world of AI research papers. I'm Charlie, and today we're joined by Cleo, an expert in technology and machine learning. We're discussing the paper ECLIPSE, a resource-efficient text-to-image prior for image generation. Cleo, can you start by giving us a rundown of what this paper is all about?
Certainly. ECLIPSE is really intriguing. It introduces a new method that has substantially fewer parameters and requires much less data compared to other state-of-the-art models. It's a contrastive learning approach that trades off diffusion methods for better efficiency while still aiming to maintain high-quality image generation based on textual prompts.
That sounds like a big deal in the text-to-image generation space. Typically, these models are resource-hungry, aren't they?
Absolutely. Traditional models like DALL-E 2 and other unclipped frameworks are giants in terms of the computational resources they need. We're talking about billions of parameters and extensive high-quality training datasets. ECLIPSE, on the other hand, significantly reduces these requirements, which is quite a leap forward.
How exactly does ECLIPSE achieve this level of efficiency? What's the secret sauce?
The core idea is the utilization of pre-trained vision language models, like CLIP. ECLIPSE distills the knowledge from these models into the text-to-image prior, which is then trained with far less data. And since it's not a diffusion method, it doesn't suffer from slow convergence, which is common in other models.
I see. And what were the results like? How does ECLIPSE stack up against the big players?
It holds up really well. In a resource-limited setting, ECLIPSE-trained priors actually outperform traditional priors with a whopping 71.6% preference score. Even when pitted against the state-of-the-art big models, ECLIPSE achieved a 63.36% preference score, which is quite impressive.
That's quite remarkable for such a resource-efficient model. What does this mean for future text-to-image model development?
It opens up a lot of possibilities, especially for smaller research teams or individual creators who may not have access to the same level of resources as larger labs. ECLIPSE levels the playing field a bit, making it easier for more people to experiment and innovate.
Certainly a game changer. Now, let's touch on something interesting, the paper's name, ECLIPSE. There's an analogy portrayed here. Can you explain that to our listeners?
Certainly. The name ECLIPSE draws an analogy to celestial events where a smaller body, like the moon, can obscure a larger one, like the sun, allowing a rare glimpse of the latter's grandeur. Similarly, ECLIPSE, the model, uses a smaller prior, akin to the moon, to reveal insights from the vast cosmos of larger pre-trained models.
What an evocative image. Its inclusion seems quite fitting. Before we wrap up, Cleo, are there any takeaways or future directions mentioned in the paper that are worth highlighting?
The paper leaves us with a promising direction for generative models. It shows that high compositional capabilities can be achieved with much leaner models, as ECLIPSE does. Going forward, I believe we'll see more research focused on refining these efficient models and exploring their application in various domains.
Thanks for sharing your expertise, Cleo. And thank you to our listeners for tuning in to Paper Brief. We hope you found this episode enlightening and that it sparks your curiosity in the ever-evolving field of AI. See you next time.